Stage box.
Information contained given by the bound. That means that not all of the information on a given area of the object is pass through the corresponding area on the top of the screen. And therefore, from the point of view of an observer observing the object through that screen, not all of the information about that object will pass through. And thus, if we think of a scenic area as having something to do with the amount of information that we can obtain about the surface of a given object, it seems reasonable to conclude that in that case, the perceived area is going to be smaller than the real area, and in particular, the perceived area is going to look as though the gravitational both sets are there, because only the amount of information can pass through the screen. And so this is a fairly heuristic argument, would need further development, but it does at least provide some indication that there is potentially a viable epistemic interpretation of at least some gravitational phenomena. So although I think the consequences of taking this epistemic interpretation of the bound and using it to explain gravitational phenomena are somewhat extreme, it's at least conceivable that there could be some epistemic aspects to certain gravitational phenomena. An alternative is, of course, to take an ontological view of the bound. And in that case, if we still think of the bound as explaining various gravitational phenomena, what we get is potentially quite a nice way of understanding why we have certain kinds of gravitational effects. And in the ontological case, that does not require us to say that gravity is in any sense epistemic. So in particular, suppose we adopt some ontological interpretation of the bound, where we say that light sheets are really just alternative representations of their boundary surface. They have the same ontology, and therefore they have the same number of degrees of freedom. Well, in that case, we can straightforwardly derive that geodesics must be focused by matter, because otherwise the light sheets would sometimes contain more information than their boundary surfaces, and that isn't possible if light sheets are just alternative representations of their boundary surfaces. So in that case, we get a fairly straightforward explanation of certain gravitational effect, and that essentially seems quite appealing. It should be noted that the deriving gravitational phenomena from the covariant bound is going to have to use various approximation. It will have to treat entropy as a fluid, for example. So this way of explaining gravitational phenomena would have the consequence that we have to regard gravity as some kind of approximate emergent phenomenon. And thus this line of argument would potentially fit in very nicely with the existing research program on emergent gravity, which again sees gravity as an approximate emergent phenomenon. So to sum up, I have set out sort of two possible routes you could take in terms of interpreting the entropy bounds. You can take the ontological route, in which we think of the entropy bounds as counting the real number of degrees of freedom on a light sheet, or you can take an epistemic
Hello, everyone. Hello, Patrizia.
Hi.
So, Patrizia, let's try getting your slides up, and we'll start immediately with the format.
Can you see my screen?
Yes. Okay, great. So, just 1 second, I want to see. Great. So, all right, so welcome everyone to another OCP TAP session. This is call number 97. Today we have Patrizia Tavella, which is going to give us a presentation about the future of UTC and agreement with UT1. As always, we'll start with a quick bio about Patrizia. So Patrizia got a degree in physics and a Ph.D. in metrology, is the director of the time department of the Bureau International de Puede Mesu. After 30 years at the Italian Metrology Institute, INRIM. So her main interests are mathematics and statistics models applied to atomic timescale. Also, she has been deeply involved in the development of the European navigation system Galileo. And in 2020, she was awarded the Enrico Fermi Prize by the Italian Physical Society. And in 2016, prior to that, she was the IEEE UFFC Distinguished Lecturer. She got a Distinguished PTTI Service Award in 2008. So with no further ado, Patrizia, the floor is yours.
Yes, thank you. Thank you for the introduction. So as you said, I work in the International Bureau of Weight and Measure, where we compute the coordinated universal time, and particularly I am responsible of this computation. And it's my pleasure to meet you all today. And you see, we had a meeting about 2 years ago, and the name was May We Get Rid of the Leap Seconds. And I'm very happy to be here again with you with a second talk, because I have two main messages for you. First, I want to say thanks. And second, I want to hear your opinion on the next step. So why thanks? You remember this is the last slide I showed you last time. We discussed the fact that the coordinated universal time has leap second, and that we wanted to change this situation. And so our governing body, which is called the General Conference of Weight and Measurements, in November 2022, proposed to change UTC, and particularly to change the maximum value between UT1 and UTC. UT1 is the rotation of the Earth, and the agreement is now at the level of 1 second. We proposed to change that. And I asked you to support this proposal, to advertise, and to arrive to a consensus. And that was 2022. And I'm happy to say that the proposal has been approved. So now it is no more a draft, it is a decision which will take place by or before 2035 by changing what is necessary. So this comes from a very long story. We discussed it a lot. Actually, discussion went on 20 years, but at least from 2022 till to be able to approve the draft resolution in 2022, there was a lot of discussion and a lot of support. So let me show you part of the video. When I gave last presentation, you see Ahmad is very serious, but Olang is very happy when hear the fact that we can change the leap second and there will be no leap second in the future. Then on Meta, there was this important event saying it's time to leave leap second in the past. And maybe some of you was involved in this document prepared with the support of Song Yabin, one with several industry writing to us and us giving their view on the leap second. And we received also a petition which was collected during the International Time and Synchronization Forum in 2021. So this is the support from the industry and for the digital company, and I would like to thank you. This was not the only one. We had also some other international organizations like the International Telecommunication Union, the telecommunication sector, who sent a document, the Union of Radio Scientists, the International Genesis Service, and others. So all together, we were able to arrive to that decision. And then there was still a very important step. The International Telecommunication Union is also involved in this decision because they are responsible for the code for transmitting UTC and particularly for transmitting the difference UT1 minus UTC. So they met at the World Radio Conference last year in November. And I have to say, after a long period of discussion, in the end, the decision of the General Conference was endorsed. And so we are now all together working towards the next step. So I don't know how much you are familiar. I think maybe you know everything by heart. So I will be very quickly in recalling which is the problem. Timekeeping is based on atomic clock, but there is an agreement between the Earth rotation and atomic clock. Let's say atomic clock are perfectly ticking. The Earth rotation is not so perfect. It is going faster, it is going slower. So we correct sometimes the atomic time to be in agreement with the Earth rotation. The atomic time is called TAI, which in French is Atomic International Time, and UTC is the Coordinated Universal Time. So you see that any time that there is a discrepancy between UTC and the rotation of the Earth, when this discrepancy is almost 1 second, we keep the atomic clock busy for 1 additional second so the Earth can be in pace with the atomic time. And we did that since 1975, 27 times. In certain period quite regularly, almost 1 second a year. Recently, no more leap second have been added since 2016. And in this moment, there are 37 seconds of difference between the atomic clock and the UTC, which has been delayed as much as necessary to be in pace with the Earth. UTC is computed at the International Office of Weight and Measurements, from where I am speaking. We are under the authority of the General Conference of Weight and Measurement, but we are not the only one involved in UTC. There is a service called International Earth Rotation and Reference System Service, which measures the position of the Earth and decide when it is time to realign atomic time with the Earth rotation. And there is, as I said, the International Telecommunication Union, which decide the code for the transmission of time signal. We try to do our best to provide the best international standards, but unfortunately, these discontinuities in UTC are a trouble for the application that are quite important because they support the infrastructure. And so, for example, the global navigation satellite system are not adding the leap second. Digital networks are not applying or applying in a different way. And also other protocols for the synchronization on the internet are applying or not applying. So it is clear that there is the standard is not adapted to the application. And so the alternative methods have been developed. So as I said, the navigation system do not add leap second, or some other application decide to repeat twice the second 59 or twice the second 00. And some other users decide to smear, which means adjust little by little to reach 1 second in 1 day or 18 hours or whatever. So we have a situation in which on the day of the leap second, depending on the source of time that you are using, you may have second of difference. And this is clearly a risk of malfunctioning for which we understood and we did our best to take another decision. Unfortunately, this decision was not very easy. So this is why it took a lot of time, because not all the country, not all the users agrees with this decision. But little by little, we were able to create a consensus on the fact that the tolerance, which is now 1 second, is too strict. It could be 1 minute, which is reached more or less after 1 century. It could even be 1 hour, and we would have thousands of years before reaching such a difference. Or it could be just unlimited, saying let's the Earth rotation and the atomic time diverge slowly. That doesn't happen tomorrow. It is a very slow process. It is clear, and I want to repeat, maybe it's not your concern, but a lot of concern has been raised on the fact that civil time should be linked to the Earth rotation, because we live on Earth, and I would say mostly emotionally, it is quite important that when we say it is noon, the sun is on our head and not too much different from what the atomic time is telling us. Clearly, there are users that need to know the position of the Earth, UT1. These users need to have this information in real time with good accuracy and good reliability. So there are services which broadcast or disseminate this information. And this is to tell you that when the leap second was decided in the 70s, it was because the civil time was used as an approximation of the rotation of the Earth, mostly for celestial navigation, pointing to the star and the planet. Nowadays, almost no one is using this type of navigation, and therefore this need is not so necessary as it was 50 years ago. And so we arrive again to this decision taken in November 2022. The maximum value will be increased. And you see, we say in or before 2035. So there is a first things which is not yet decided, not later than 2035, maybe sooner. And then which will be the new maximum value? The request is that a continuity should be ensured for at least 1 century. And we have been charged that the new maximum value, a plan for the implementation, and all the detail are decided for the next General Conference in 2026. And so this is why we are now working on this additional detail. So a group has been created, and we are trying to evaluate which is the best value for the extended tolerance. what shall we do when the tolerance is reached? Which type of adjustment procedure is necessary? A step in time, a step in frequency. So we are trying to understand what has to be done. Also, we consider that as this decision is affecting very far the future, maybe it's better if we revise this decision with a certain periodicity, because we are not sure now to take the best decision for the future. Maybe in the next years, some new model will be able to explain the Earth rotation in a better way. So this is to be decided, and also we have to decide the implementation date. And this is where I would like to have your view, because as last time it was very important to have the people working every day in the need of network synchronization. It was very important to have your view, and your contribution was considered and gave the pressure to the need of a decision. This time we can do something similar. So for the tolerance, there are 3 options. A smaller, let's say, tolerance, which is 1 minute or a few minutes, 1 hour, which could be connected to the daylight saving time. We will never get back from daylight saving time, or just no limit, and let's see what happens in the future. We are evaluating how this choice is related to the time zone. We are also in doubt if we should really fix all the detail for something that will happen at least in 100 years, maybe in a few thousand years. It seems really a bit arrogant now to take all the decision for the future. And we have to decide when. So the International Telecommunication, the radio conference last November that I mentioned, expressed the preference for 2035 to give time to all the member states to be prepared for this change. But we have other member states which are pushing for a quicker implementation, particularly for the fact that a negative leap second may be necessary. So I don't know if you are familiar with this discussion. This is a plot that you can find on the International Earth Rotation Center. This is UT1 minus UTC. So this is the rotation of the Earth with respect to UTC. This is time. It's a datation in modified Julian date, but any vertical line is a leap second. So you can see here in 2016 is the last leap second. Then the offset between the Earth and the atomic time decreased. And in principle, as usually it decreases, we would have expected going down towards -1 second and then a new leap second. But look what happened in June 2020. We reached a slowing down, like a stop of this negative trend, and a positive trend went on till now. And the blue one is the prediction. So we are really scared because the Earth has gained 200 milliseconds in 3 years. If it should continue like that, maybe it will not be a leap second to be added, but a leap second to be removed. So this is why we call it negative leap second. The negative leap second has never been applied, never been tested. Some applications are not even designed to cope with this case. So we have a certain number of member states and stakeholders saying, you are crazy, we cannot go towards this situation, do something before. So how is a negative leap second probable? You may see just today, I think 1 hour ago, on Nature, a paper has been published explaining that thanks to the global warming, the negative leap second will be probably in 2029. And we should be happy that melting ice has delayed this necessity that, according to this author, could have asked for a negative leap second even before than that. But if you look on another paper, which is of about 1 year ago, the conclusions are almost as likely as not to experience a negative leap second the next 12 years. And another paper, these are papers from people working in mostly in Earth rotation, so people that are expert. Another group says not reliable prediction is possible in the long term. Let's observe the Earth rotation and let the future generation decide. So unfortunately, this prediction you see is very short. This is 3 months. 6 months. And we cannot go far in the future. The expert in Earth rotation cannot go far in the future. So in this moment, we do not know how much is the risk of a negative leap second if we wait till 2035 for the implementation of the change in UTC. So the date for the change is still open, and there is a preference for 2035. Then, which is the new tolerance? The new tolerance is, you may imagine, raising a lot of discussion and a lot of idea. I would like to present you an idea which was made public in the Institute of Navigation Precise Time and Time Interval meeting last January by Judah Levine from NIST. I think he is a personality, you may know him. He's the timekeeper in US. His idea is to increase the tolerance to 1 minute because he says it is small enough not to create a problem in the GNSS system, which are broadcasting the difference UT1 minus UTC. It is small, so the people will not really see much difference between the position of the sun and the civil time. And so is something that he thinks can be easily acceptable. And also he says, do not wait to have 1 minute to make a correction, but he proposes that small periodic deterministic adjustment are added. So for example, we could add 10% of the tolerance every 10 years. Suppose the tolerance is 1 minute. Every 6 years, we add 10 seconds. So if we decided, 6 seconds, 10% every 10 years. So if we had decided that in 1972, we would have adjusted in 80, 90, 2000, 2010, 2020, and 2030, 6 seconds each time. And for sure, if you do something deterministic and algorithmic with respect to the rotation of the Earth, which is not regular, there will be at a certain moment the need to resynchronize and readjust again. This could be every 50 or 100 years. And in the same proposal, Judah Levine says 1 hour is something that he doesn't like. First, because it comes very rarely, every few thousand years. So it will be a big event. Maybe any one of us will not see these events. So will be applied correctly, will be a mess because it's such a big correction. And then if you wait 1 year, the sun will not be on your head. Sorry, if you have 1 hour of tolerance, the sun will not be on your head when civil time is noon. And so this may create some emotional discomfort, even if, to my view, this is not a huge problem because, for example, in Europe, we use European Central Time from Poland to Spain, and there are 3 hours difference, and we all use the same time. Not to speak about China, which is using Beijing time, while China spans 5 time zone. Anyway, this is one of the proposals which is quite disseminated and that has a certain success because people say, okay, we do not let the offset grow too much. 1 minute is something which is small and which is acceptable. There are other ideas. So for example, why don't we say the tolerance is very big? We need to say a number for the tolerance. We cannot say infinite, because for example, in the global navigation satellite system, they transmit the difference between UT1 and UTC, and they have a certain number of bits for the transmission of this value. So we have to say how big can be this value so they can allocate the correct number of bits. Let's say a big number, let's say 1 hour, and do not do anything. So this idea is, instead of fixing the tolerance, let's fix a time interval at which we will do something. So we start doing nothing for 100 years. And then after 100 years, we see how much offset has been gained, and they will decide if it is time to readjust. So the adjustment clearly will not be always the same, but it will be every 100 years. And so it's something that we can keep in mind. We will disseminate this information. It will be part of the culture that every 100 years we have to do something. This proposal as yes and no, people are supporting or not supporting. And so this is why I am here with you. Please give me your idea. We have to think what is better. We have two clocks. One is Mother Earth, on which we live, and believe a big number of people wants to keep an agreement between timekeeping and Earth rotation. We have atomic clocks, which underpin the most important application, and synchronization is a must in several applications. So we need both clock, and it will be very difficult to keep them in agreement. Whatever is the solution, someone will not be happy. So I thank you for your attention, and I'm ready with my paper to write your idea and to listen to your thoughts.
Thank you very much, Patrizia. Yeah, so let's open the floor and ask questions, get comments, and so on. And maybe again, just as a icebreaker, I will start myself. I was just thinking, like, I mean, when we were like writing all this, everything about, you know, the sleep cycle and supporting this effort of freezing the sleep cycle practice and so on, we have 24 time zones. And unless you have like a perfect representation for that time zone to be exactly at the middle of it, you always have this tolerance of an hour jiggling back and forth. I mean, yeah, I mean, worst case, or like right in the middle, half an hour or whatever. I still don't understand. Like, we came to the consensus to have like 24 hours time zones, like allowing an hour of tolerance. Yet we are worrying about like a second, or I mean, it will be great. Another thing also, like Patrizia, if you can show like we have this, that you're tracking UTC versus UT1 without, let's say, the adjustments, just like basically showing like the trend of how like the rotation changed, and then like at 2020, basically where it's reached an extremum and it's going further.
You mean this one?
With including also 2020, and onward.
Yeah, this is for the future.
Yeah.
Yeah.
Without,
but we don't know.
Without the corrections, you know, it looks very nice basically I'm saying that graph needs an update, because that one stops at 2024, at 2015. So. All right, Heiko.
Yes, thanks a lot. Yeah, just one thing. I believe that doing nothing for 100 years sounds very nice to me, right? question is really who needs UT1 and who needs UT1 to be aligned with UTC. I understand this is a, let's say, cultural and traditional issue, but we also have to keep in mind the technical part here. I strongly believe that no one who's on the call here, no one who is making any decisions here knows how the world looks like in 100 years, let alone in 5,000 years. So exactly. I think it is moot to think about 1 hour, even 1 minute, because you don't know what happens in the next 100 years. In 5,000 years, humanity will either be extinct, right? Or we will be commuting between Mars and Alpha Centauri. So, and in that case, the question is, okay, in 5,000 years, is anyone who still lives on Earth really worried about 1 hour of a difference where the sun basically is at its highest point in the sky, which, by the way, is not true for a lot of places on this Earth. It's only true for the, let's say, a very small part of each time zone. So it is not really an issue to me. So I believe we should stop introducing leap seconds as quickly as possible, basically now, right? We should not do anything and leave this to future generations to come up with solutions for the problems that may arise in 100 years from now. It's not up to us to decide anything. And if we decide something and it's wrong, the decision will be corrected by our kids and grandkids and their grandkids anyways. So it doesn't really make sense to take a decision now. Thanks.
Aiko, thanks. I completely share your point, and I would be happy you say that everywhere, because it is in this community, I understand, speaking to you, probably this is the most shared view. But I tell you that when I am in other places, it is not like that. So who needs UT1? Mostly astronomers need UT1, and people needing to points to spacecraft, for example, that need to know where they are on the Earth and how the Earth is oriented with respect to the sky. And for important application, having UTC close to the rotation of the Earth within 1 second, which means about 400 meter uncertainty, is something which is not good for high accuracy application. So for astronomy and space application, they use already value which are published by NASA or other organizations, which are much more accurate than 1 second. Still, amateur astronomers or some other organization feel that there is a value in having UTC as a good approximation of the rotation of the Earth. Good, I mean, within 1 second, which means 400 meters uncertainty, which for some application is not so bad. But so we have to take care of that. I think that this information should be available everywhere. If UTC cannot be used as a proxy of UT1, people needing UT1 need to have the information, which should be machine readable, reliable, secure, so secured. So we need to give a good type of information, but I completely agree that it, as I said, it seems to me really arrogant to decide now for what will happen in 100 or 1,000 years.
So one thing may I add. So that 400 meter is basically with the consideration of, let's say, let's say clock skewness. Let's put it just here for basically UT1 minus UTC. Let's say clock skewness, just for simple terminology, right?
Yeah, when you are on the equator and you point to a star, exactly. If you use UTC as an approximation of UT1, you make an error of 400 meters in pointing to.
That is for a given point where this is calibrated. But if you move Now, in that time zone, you will have that even worse.
No, because UTC is not related to the time zone.
UTC
UTC,
is for that.
no,
it-
no.
no,
You
okay,
don't, the time zone is UTC +1, +2,
That's right, that's
+4,
right,
but this
yes.
is for civil timekeeping. But UTC is always all over the world, it remains UTC. So once you know UTC and you can have clock giving UTC, you know that within 1 second, it is also UT1. And so this gives you an error, which in some cases is acceptable.
That's right. So what I meant is, like, let's say there is one UT1, of course, for the planet based on the I think it's a sidereal. Of course, it's a sidereal. It's not based on the rotation of itself. So now, with that, there is a on what angle you are in with respect to the axis of rotation. You have basically your offset, and you calculate what you need, and so on.
Yes.
So
Yeah,
that
people,
information, that added information comes from the GPS. So GPS might as well, I mean, GPS sends now the leap second information and so on. GPS can add also, let's say, sporadically once every 15 minutes or something, once an hour or whatever, the correction that you need for a frozen UTC to UT1. And then
yes,
everyone can use it, and everyone is happy. Like my thing is, like, I don't understand, why do I need to combine, let's say, reading glasses and a microscope? A microscope is for one purpose, reading glasses are for something else. So UTC is just like the one that provides for, I mean, normal day-to-day things. You can care less, and as human evolves more, we're getting more indoor. So, and UT1, you keep it just for those systems, and you provide by some good method, let's say the offset, and whoever needs it can use it. I don't think there's any, like, I mean, even my toy telescope has a GPS receiver for the star tracker. So
yeah,
don't get it really.
So I've been struggling to understand, like, what's the significance here. I agree with Heiko's comments and your comments. I think we can have a higher tolerance and kick the can a little bit, no problem. But I'm trying to put myself in the other shoes of understanding why this is an issue. And the only thing I can come up with is because transactional systems are based on some of this timing. And so perhaps, there's an unwinding of transactional systems or a problem that gets caused. And some of these transactional systems could be, related to transportation and related to public safety and some other things that it might cause some problems every so often if you don't have, some level of precision, I guess you'd say. But but other than that, I can't come up with a really clear argument of why to do anything right now. I'm struggling.
What we have discovered till now, we have tried to speak with all the different communities, and what we have found is that who needs UT1 are the astronomers and the people working in space application, where they have to follow, to point to a star or to a planet or to a probe, and they need to know how the Earth is positioned with respect to that bodies. And as I said, people needing high precision in this activity need more accuracy than 1 second in the knowledge of the value of UT1. So this approximation that UTC is a proxy for UT1 within 1 second was good in the 70s, and it is also used nowadays. But as you say, more precise information can be available on the internet, because there are NASA, for example, or the International Earth Rotation is disseminating on the internet in real time this value with much more accuracy. And also GPS, GLONASS, the Chinese Beidou are transmitting this value. So there are other sources of information. the use of UTC ex proxy of UT1 is not really an issue. I understand someone says yes, because legacy software, for example, for amateur astronomers, they say when I bought my telescope, there was a software and the software is based on UTC. But Ahmad is saying when I buy a telescope, there is a GPS inside. So who is really working without GPS or GNSS today?
Yeah, like another question I have for you, Patrizia, is like in the discussion that we had, like again with specific country, and they were raising this issue that they were saying that like their satellites will have a problem because they are planned to have like the leap second applied or something. I really didn't understand why is that an issue, because leap second is not predictable anyways. I mean, in the format that we have to, you don't have it as a closed system. You have to tell the system like, hey, there is going to be a leap second and they have to apply. So if you don't, why was that a concern? Like, do you remember what I'm talking about, right?
No, I'm not sure.
Which, I mean, in the end, we concluded that was more like a political thing, you know, like for their satellites.
Yeah, who is not in agreement with this was mostly for technical reasons, as I said, like astronomers or people pointing to space object, but most of the criticism came from emotional reasons, because people say, I live on the Earth and I want to be in pace with the Earth, and I want it is noon when the sun is on my head. And this is an emotional reaction which was let me say, pumped a lot for political reasons by the country that didn't want to change. But now this is done because we have been working a lot, thanks to your support. And the General Conference took a decision that the leap second will be discontinued. So we don't need to go back to this decision, I hope. Yes. We just need to fix the detail. So we extend the tolerance, because we don't want to say that UTC is not taken in pace with the Earth rotation. It is still taken in pace, but with a larger tolerance. So shall we fix the tolerance, 1 minute, 1 hour? Shall we say, let's do nothing and let's keep this discussion alive? So for example, what someone says is, every 20, 30 years, the General Conference should discuss again this issue, not to be forgot, and to give the clear perception that we are taking care and that we think about to that regularly, and we see if we can make a certain adjustment every 100 years. That could be 1 minute, could be 0, could be negative. We don't know, because we don't know exactly what happens with the Earth. And then steps by 100 years, we see what happens. And as Heiko was saying, we will be maybe extinct, or maybe we will be working on Mars, and we will go up and down from Mars, the Moon, and the Earth, and we will have figured out much better how to keep time. And surely you imagine traveling to the Moon or to Mars and applying a leap second in the middle of your travel. So that's really something crazy. So that will not be done, but soon or later, an adjustment is to be done, because there will never be a consensus on the fact that this offset will grow infinitely. At a certain moment, an adjustment is necessary. But this certain moment may be very far in the future.
Yes. Anyone else wants to add any comment? Please, Dr. Kinson. I think you're muted. You're muted. All right. While we're reading, I think, with Dr. Kinson. Anyone else? So, Patrizia, you said some of the constellations, they are already reporting the UTC minus UT1?
Yes.
And
Yes. So, for
that's not
example,
GPS, of course.
yeah. So the GPS is disseminating this information, and they have a certain number of bits which allow this value to grow till 64 seconds. This is why in this proposal, Judah says, if we choose 1 minute, it will be smaller than 64 seconds, which is the maximum value which can now be broadcast by GPS. And the same is for the Chinese Beidou system. The Russian GLONASS needs to be updated because the current GLONASS can only accommodate a value which is smaller than 1 second. But the new generation of the Russian GLONASS satellite system is already in place. There are already 9, I think, out of 27, I am not sure, but there are a certain number of satellites which have been already updated, and they now allocate enough space for this value to be 256 seconds. So 1 minute GPS has nothing to do. If it is 1 hour, all the system have something to do. But also this seems to me a problem which is not really true, because navigation system change the satellite almost every 15 years. So the lifetime of satellite is 10, 15, 20 years. So what we need to do is, if it is 1 minute correction, is in 100 years or in 1,000 years. So all the GNSS will be updated before that moment. So even if today they are not ready, a update system are always going on. And so I think that all the system broadcasting this information can accommodate the value that we want to decide.
Heiko, go ahead.
Yeah, I mean, let's face it, you need to be very optimistic or pessimistic. I'm not sure which way to look at this when you think that in 100 years the GNSS satellites will still keep sending exactly the same protocol messages with the same bit lengths and so on that we have today. I mean, if this is really still an issue in 100 years, and we were talking about these 64 seconds being basically accumulated over 100 years approximately, then I don't think we will have GNSS as we know it today in 100 years from now. There will be something new, and as soon as let's say there is going to be something new, whoever is setting up this system will hopefully look at the timing dissemination messages in that solution, and will add more bits to allow disseminating a larger of that than the 64 seconds that are currently allowed in the current ICD of GPS. And yeah, so this is again something where I'm puzzled that someone really believes we should deal with a problem and try to propose a solution for something that is even 50 years in the future, right? Think about what the world looked like in 50 years ago, and then imagine that someone from 50 years ago would try to come up with a solution for a problem that probably doesn't even exist anymore. So I don't think it's something to be worried about. We should keep it as it is and leave this to future generations.
Completely agree. But as I said, it is not so shared in all the community. But I completely agree. It's stupid to think what will happen in 100 years now.
Bijan?
Yeah. You know, I agree with Heiko. You know, I've always had this view that I was irritated there's not a separation of concerns where we were talking about synchronization and the definition of time, and it's very separate from the time and date, right? The date. And so, you know, I was always annoyed, like, why don't we just take the absolute time and then derive the date from a local point of consumption, right? Instead of, you know, implementing this up the chain as far as we have. Like it kind of doesn't need to happen at the GPS layer, if you ask me. So
So,
I guess that's another reason to kick the can, like do nothing.
All right, so I think you have a unanimous consensus here that at least this community thinks we simply should not do anything and leave it to the future.
yeah. So I will be happy to inform that I spoke with some industrial representative, and this is the view. And for sure, as this decision is to be taken in 2026, I am sure that still you will hear some presentation, some papers, some different point of view. So let's see if we can work together, and I'm very happy and thanks for having given me this possibility today. We will have maybe other possibility of exchange, and in any case, if it would also be good if you discuss this item in your community and you help in having the understanding of the correct proportion of the things, because as we say, we are discussing things which has no meaning today, because it will happen in 100 years or 1,000 years, but people are scared as it was a problem now. And so we need to put the correct proportionality in what we are saying.
I think it's also good to have basically provisioned, let's say, a document, non-enforced, just as like, let's say, suggestions or something that can be prepared and then will be kept with this whole effort that, let's say, in 100 years, when there is, let's say, some quorum trying to do something, they can look back at like, these are the suggestions. And then by that, you're releasing that, you know, the urge that certain people have, like, for example, what Judah is mentioning, I think it's very valuable, I mean, to the people in the future to look at, like, by the way, you inherited this quote unquote problem, and these were the suggestions that were given to you, like if you face, let's say, an offset of such and such to do such and such. So I think that way it really gives it a graceful closure rather than do nothing, just delete everything and step back, you know, rather than that, like, okay, let's just make it in form of a bunch of suggestions that people can look into while it goes in the future. Because as everyone mentioned, looking back, as Heiko mentioned, you know, looking back 50 years ago, problems they had 50 years ago to now, the same thing that in 50 years they will have when they look back at us, and then so on and so forth. This is like just how we progress. Dugan.
Yeah, I think it's a strange thing to kick the can this far down the road. I mean, just it seems like you would have to have, you know, an order of monks keeping track of like this one piece of knowledge and say like, oh, it doesn't matter now, but tell your kids and then pass it on to the next generation, and then, you know, 4 generations down the line they'll have to do something. But we have to keep this knowledge and really make sure that that the next people are aware of it.
And this community is very familiar with the concept of holdover. Imagine you're putting an idea and you want it to have a over of 100 years. So, Dennis.
So I've come to the conclusion that I'm viewing this a little differently, in that, you know, I agree with the general consensus that, you know, it'd be kind of absurd to say now that, you know, schedule some change for 100 years from now based on the data. But it's really more because these decisions are all made by people on these various international committees whose membership is going to change. And even if the powers that be now decide to schedule something for 21-24, 30 years from now, the composition of these committees is going to be all different. And if somehow the Earth rotation parameters are a lot different, they are going to elect to make a change. So, even if the bodies decided, okay, we're gonna schedule something for precisely 100 years from now, that's subject to change anyway, just based on all the stuff in the middle. All we can do right now is say, okay, we know we know we don't want to do anything right now, and if the same people are in charge in 10 years, probably the decision is going to be the same, right? So I'm in favor of thinking about it like one of the reasons I think Judah put forth the notion that he did of doing something every 10 years is just to make sure that some action gets taken and that it's not totally forgotten.
Yes.
But having it being, rare enough, like every 10 years means that, if you have to shut down the stock exchanges for it because people are worried about trading during that time when the time isn't regular, they can do that once every 10 years, right? So that might be the only argument I can see for mandating some action is just to keep it in people's minds that yes, we have to do this, and we'll adjust it by a small amount just to keep it in everybody's heads. And so you don't get to the point where 40 years from now, nobody on the committee has any experience with this, and they're getting him out in his retirement home to try to figure out what to do.
It's like if I understand what you're saying, like the continuation of the effort.
Right.
Yeah.
Yeah, but you were also saying if we do nothing for a long period, people will forget that there is this problem. So if we do something every 10 years, at least this remains in the culture. Is that what you propose?
Yeah, I think at least I understand. That's what I take from how you presented Judah's proposal, and that at least to me has some value of making sure that it's at least brought up. I think 10 years might be the limit as to how often something needs to be brought up before it's brought up at least twice in everyone's careers.
The logic is that the Earth rotation is, aperiodic, and it will always change forever, right? So there is some logic to that, and there are other standards that are set on like long-term basis like that. Like I can think of the World Radio Conference is like what, every 7 or 10 years, I forget which. And so yeah, there are other groups that do that.
Sorry, can you say it again? You ask if there are other groups doing what?
No. I said there are other groups. There is like a World Radio Conference that meets like, I don't know, forget the number, 7 years, 10 years, something like that. And it's a global thing. UN nations get together and they set the frequency bands and standards, and it happens very long periods.
Yeah, these big international organizations have periodic meetings of all the member states where they take decision, and it is the same as we do with the General Conference of Weight and Measures. I understand that there is a value in keeping in mind that every 10 years we have to do something because that keeps the memory. But unfortunately, as we are at the moment facing something which is not predictable and not regular, we can decide that we make plus 5 seconds every 10 years, fine. But in 50, 100 years, we will realize that we have corrected too much or not enough. And so an adjustment will always be necessary because we risk to go in the wrong direction because even we don't know if it is positive or negative. So yes, it's a good, for certain aspects, it's a good idea, but you have to put in your system 5 seconds every 10 years. This is regular, but then every 50 years or 100 years, an adjustment which is not deterministic, that will be on the basis of the observation. And so in any case, we have to face this problem that sooner or later, something which is not deterministic has to be applied.
All right. Any more questions, comments? Hearing none, we are on top of the hour, so we'll adjourn. And thank you again, Patrizia, for this great presentation and roundtable, I will say. And we'll see everyone in 2 weeks by a presentation from Paul Borrell about clock coherence from terrestrial micro data centers to Alpha Centauri. So
discuss what to do with him to see when he travels to Alpha Centauri, what he wants to do.
He's actually here. Paul is here.
Yeah, okay. Thank you. Bye-bye. Good luck.
Thank you. Bye-bye.
Bye.
Bye.
Thank you.
Thank you. Bye.
Thank you so much.